Hello guys, welcome to my YouTube channel Anil Physics Academy. In my channel, I taught you how to add two vectors. I taught you how to subtract two vectors. In today's video, we are going to learn how to multiply two vectors. There are two kinds of multiplication of vectors. The first is a scalar product or dot product of two vectors, and the second is vector product or cross product of two vectors. And in today's video, we will learn about a scalar product or dot product of two vectors. Before proceeding further, one thing we should know that the division of two vectors is not defined. That is, vector A by vector B, this is not defined. It means we cannot divide a vector by another vector. So division of two vectors is meaningless. So keep this fact always in your mind. So let us start learning a scalar product or dot product of two vectors. Let there be two vectors. This is vector A and this is vector B. And theta is the angle between vectors A and B. So the scalar product or dot product of two vectors is denoted by vector A dot vector B, and it is equal to magnitude of vector A into magnitude of vector B and cos theta, where theta is the angle between vector A and vector B. So A dot B means a scalar product of two vectors A and B is equal to magnitude of A, magnitude of B and cos theta. Now what is B dot A? B dot A. B dot A is equal to B into A cos theta. So this can also be written as AB cos theta. So we can see that A dot B is equal to B dot A. A dot B is equal to B dot A. So what we conclude that the dot product of two vectors is commutative. And one thing also we can see that the dot product of two vectors is a scalar quantity. AB cos theta is a scalar quantity because A is scalar, B is a scalar and cos theta is also a scalar. So always remember the dot product of two vectors is a scalar physical quantity and the dot product of two vectors is commutative. Now let us proceed further. Now we will learn the dot product between the unit vector along Cartesian coordinate axis. We know I cap is unit vector along x-axis. Let us make the Cartesian coordinate axis. This is I cap, this is j cap, this is unit vector along y axis. I cap is unit vector along x axis and k cap is unit vector along z axis. The angle between these these unit vectors is 90 degree. It means angle between I cap and j cap is 90 degree, angle between I cap and k cap is 90 degree, angle between j cap and k cap is 90 degree. So what is I cap dot I cap? Magnitude of I cap is 1 and magnitude of this I cap is also 1, and cos, what is the angle between these two vectors? These are the same vectors, so the angle between these two is 0 degree is equal to 0 degree is equal to cos 0 has value 1 is equal to 1. Similarly, we can calculate j cap dot j cap is equal to also 1 and k cap dot k cap is also equal to 1. So we can see that the unit vector along the Cartesian coordinate axis is 1 if the unit vectors are the same. Now we will see what is the unit vector of two unit vectors when they are different. That is, what is the unit vector or the dot product of I cap dot j cap? So I cap has magnitude 1, j cap has magnitude 1, and angle between I cap and j cap is, I have said earlier, it is 90 degree, cos 90, and cos 90 has value 0. This is equal to 0. And similarly, what is j cap dot I cap? As we learnt that the dot product of two vectors is commutative. So I cap dot j cap is equal to j cap dot I cap. This is equal to 0. Similarly, what is j cap dot k cap is equal to 0. K cap dot I cap is equal to 0. The summary is, if the two vectors along Cartesian coordinate system, two unit vectors along the Cartesian coordinate system are the same, then their dot product is 1. And if they are different, their dot product is 0. Now we will see what is the dot product of a vector with itself. Let there be a vector A, and we want to find a dot product of this vector with itself, that is vector A dot vector A. So this is equal to magnitude of vector A and magnitude of vector A, and since they are the same vector, so angle between them is 0 degree, is equal to cos 0 degree, is equal to A square. So the dot product of a vector with itself is equal to a square of its magnitude. We can see from here. Now we will learn how can we find dot product of two vectors when they are written in component form. For example, let A be a vector given as ax I cap plus ay j cap plus az k cap, and B is a vector given as bx I cap plus by j cap plus bz k cap. So what is A dot B? We have to find vector A dot vector B. This is equal to ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap. Now we will find dot product of this ax I cap with all these, and this is equal to ax bx dot I dot I. So dot product of this with this, what is ax by I cap dot j cap, and dot product of this with this plus ax bz I cap dot k cap plus. Now we will find dot product of this term with all these. So dot product of this with this is equal to ay bx j cap dot j cap plus this with this ay by j cap dot j cap, this with this ay bz j cap dot k cap plus. Now we will find dot product of this term with all these. This is equal to az bx k cap dot I cap plus az by k cap dot j cap plus az bz k cap dot k cap. So we can as we have seen earlier in this lecture that I dot I is equal to 1, I cap dot I cap is equal to 1. So this is equal to, this term is equal to ax bx, and I cap dot j cap is equal to 0. So this term becomes 0. Similarly, I dot k cap is also 0, and j cap dot j cap is equal to 1. So this is equal to, this is j I cap, sorry, this is I cap. So this is also 0 plus j cap dot j cap is equal to 1. So this is equal to ay by j cap dot k cap is equal to 0 plus k cap dot I cap is equal to 0. Then k cap dot j cap is equal to 0 and k cap dot k cap is equal to 1. So az bz. So we get the final result, final formula, vector A dot vector B is equal to ax bx plus AY BY plus AZ BZ. So what we see, what is the formula of dot product of two vectors when the vectors are written in component form? To find the dot product of two vectors when the vectors are written in component form, we multiply the corresponding components of the vector and add them. We multiply the x component of vector A with the x component of vector B. We multiply y component of vector A with y component of vector B. We multiply z component of vector A with z component of vector B and add them. This is the A dot B. Now what happens when we find when we try to find the dot product of a vector with itself when the vector is written in component form? That is, what is vector A dot vector A when it is written in component form? So proceeding in the same manner, we find that vector A dot vector A is equal to AX square plus AY square plus AZ square. So guys, that's all for today's video. In this next video, which is very important video, we will solve many problems from the dot product of two vectors. So guys, please subscribe to my channel. Thank you very much.